fall asleep on this one. I still encourage you to keep working through the questions because there's always these little things that throw you off at the end. Signs, missing signs or whatnot. And you can do well on this if you stay put, because there aren't as many rules as vehicle finance, right? Like basically, if you know how to use the formulas, you plug them in and you go. All right, so page 282, we have a ship that travels south from the port for 2 hours at this speed, right? So if you're traveling at 35 kilometers an hour, then for 2 hours, that'd be 70 kilometers. So we put 70 kilometers in here because 2 hours times 35 kilometers per hour gives you a distance of 70 kilometers that you will have covered, right? So this is our first leg of the trip. Then changes course and travels. This you don't really need to know how to, just go by the diagram, but it's saying that it goes 20 degrees west of south. So if this is south, it turns 20 degrees towards the west. So this angle right here is 20 degrees, and I need to talk about that in a bit. Let's just continue with it, having to travel 3 hours at the same speed. So 3 hours times 35 kilometers an hour, that would be 105 kilometers, right? So this stretch traveled here in terms of an actual length of this side of the triangle will be 105 kilometers, okay? And this is where it gets interesting, okay? This, a straight line, right, has an angle of 180 degrees. So this angle right here is found by just going 180 minus the 20 that's on this side. So you know that the angle inside this triangle, because you need the inside angle, the outside doesn't really help you, but these are called supplementary angles, right? The 60 and the 20, they're called supplementary angles, okay? Add up to 180. And it's not terribly crucial that you remember the term supplementary, but just that a straight line, right? Maybe on the side here, if you have a straight line going in any direction, right, this would be 180 degrees. Right? The whole thing is 180 degrees. But if you come and cut it, if you come in and cut it like this, and let's say this is 40, right, then this side must be 140, right? Like combined, they always add up to 180. So that's what you need to remember. You will see that from time to time moving forward, where you might think you don't have enough information, but this is actually worth a full mark here. Okay, so 160 goes in there, and now we have an SAS, right? We have a side, the angle in between, and another side. So we have to use cosine law. And the formula should be on your study sheet. So I'm going to call this X here, because they're asking, right, how far is the port after 5 hours? So they're asking for this because you're traveling 2 hours down and then 3 hours this way. So how far is the boat from the port in these 5 hours? So they're asking for that distance there. Okay, so we go x squared is equal to, take the other two sides and square them. That's the pattern. And you go minus 2 times 105 times 70 times cosine of 160 degrees. And one thing we know is that cosine of 160, right? That's obtuse. Will be negative, right? If you type in cosine of 160, why don't you go ahead and do that? I don't know what it is, but I can guarantee you that it's going to be negative. So if you go cosine of 160, there's that negative sign in front of it, right? That's what I just want you to know that. Always be aware of that. Okay. If you have a decent calculator, they're all decent, but you know what I mean, right? Like the one where you can actually just type all of this in and it gives you one number. Go for it at this point, right? So we go 105 squared plus 70 squared minus 2 times 105 times 70 times cosine of 160. If you have one of these, you don't even need to worry about the negative because it'll take care of it for you. But if you're doing it in steps, you will be in trouble if you don't know that. So I'll write everything down, the whole thing. 29,738.48153. It's very doable. I'm not asking you something unreasonable here. So 172.45. If you round to 2 decimals, which is always what we want, 172.45. And we are in kilometers. And it makes sense, right? It's the longest side, and it's confirmed, right? It is the longest side. Okay, so this is a good example. This has everything. It has some speed where you have to figure out the distance. It has supplementary angles, right? So it's the whole, all components included. It has an obtuse angle, right? So if you're doing this in steps, because what I need you to understand if you're doing this in steps, this will be negative, right? This gives a negative answer, and this negative and that negative will turn positive. So the whole thing ends up being, so you end up saying 105 squared plus 70 squared plus whatever you get here. That's only if you're doing it in steps, okay? If you're able to type this in all in one shot, don't even worry about it. Okay, next question. Ginger is a beach lifeguard. She must set up buoys for swimming competition. Buoys are these little orange things that swim right on lakes or whatever. They sometimes they try to make sure you understand that there's a hazardous, like if you're boating or whatever. Sometimes they're used to like fence in a safe swimming zone, right? Swimmers will jump off the pier. Here it is. Swim around one buoy, change directions, swim around the second one, then head back to the pier. The first buoy is 300 meters from the pier, so we're here. The diagram is provided. Second one is 200 from the pier. The angle between them is 60 degrees. How long is the swim route? So always pay attention from now on to what are they asking you for, right? The swim route is all of it, right? Because they'll be starting here, swimming to here, around it, going there, and then back, right? So they're actually asking for the whole distance around. And part of that work is to find out what this is, right? We know this is an SAS, so I have to use cosine law, right? So we're going to go x squared is equal to 200 squared plus 300 squared minus 2 times 200 times 300 times cosine of 60. I could have my answer key, but the reason why I work through these like that, because it reminds me of what could go wrong, and then I can warn you. Right, you get 70,000. Take the square root of that, that's 264.58, and we are in meters. Swim route. Oh, sorry. I think I didn't read it right. I'm reading it again to make sure before I... swimmers will jump off the pier, swim around one buoy, swim around a second buoy, then head back to the pier. Yeah, that they want the whole thing. So we're going to go 300 plus 264.58 plus 200. So this is 500, so that's 764.58 meters. I asked you to do 282, 283, right? So I might just give you the answers to the other ones unless somebody has a question. So write this down. If I'm going to leave it for a bit if you're writing this down. This week and then next week and then it's spring break, right? So we're very close. All right. Go ahead, Christine, finish it. All right, what do we have next page? We have the bike there, right? Yeah, that's it. I thought I had, on one of my booklets, I had an example there, yeah. Okay. 33. On the triangular bike frame of a bicycle, the distance between the seat to the handlebars is 52. The handlebars to the gears is 56. So they're already labeling it for you, and there are the capital letters as well. And the gears to the seat is 42. What is the angle formed at S? So they're asking for this angle right here. So you should be able to see that there's a triangle in there, and they want this angle there. So right away, we recognize that all three sides are given. So it's this. So let's imagine we don't know if it's sine law, cosine law. Now we know for sure, right? So we'll start. We want that one right there. So you start with this cosine of S. Make sure it's a nice capital S there. And no matter what you do, you're gonna go minus 56 squared at the end. Make sure that the angle and the side are across, and you have the negative there. And then take the other two sides, square and add them. See, these are the little things. Like some students think I got it, but then they forget to square on the test. They just go 42, 52 minus 56. Right? You don't square them, it's going to be off. And the only way to go around that is to keep practicing, keep doing these, follow along, right? Cosine of S, we'll type in the top and figure out what that is. That's negative 390. There's that negative, don't drop it, right? And then it's 2 times 42 times 52. That's 4368. And I will highlight that and make sure you do the same, right? Angle will be obtuse, right? It'll be, right, bigger than 90. That's not very clear. That looks like just barely over 90. So let's make sure we, right, something like that. So obtuse, it'll be greater than 90. So we find out either next to it, but I used up that space. I'm going to divide these two. I'm going to go negative 390 divided by 4368, and that's negative 0.0893. If you round, here it is. Look at the calculator and make sure you understand, right? You want to round to 4 decimals, so this is where you want to truncate it, you want to cut it. So before you write it down, you look at the neighbor. If it's 5 or bigger, this bumps up to 3 in this case, right? And then you take the inverse. So last step would be S is equal to cosine inverse of negative 0.0893. I'm going to take the inverse of what I see on my screen. You're allowed to do that. 95.12 degrees. Obtuse greater than 90 degrees. I might ask you questions on a test. What can you say about, I might just give you something like this. Without using your calculator, what can you say about the angle that you will get out of this? And I don't want the answer. I just want you to say the angle will be obtuse or greater than 90 because of that negative, right? Okay, now we're going to go back to 270. I'm just going to check here. 271, right? Let's go back to 271. Let's do some sine law. Okay, sine law is a little trickier. And this is what you're going to start seeing more. It's not very obvious that there's a pair, right? Cosine law is very obvious. It's very easy to identify. Sine law sometimes doesn't, okay? So the examples you're going to see here show right away that you have a pair. But I'll pick up some that don't. So we'll do the tree, for example, and so this is page 271. So let's pretend we don't know, but we're looking at it, right? And we're like, okay, we see this pair, and I encourage you to do this. You can use sine law if you at all are able to somehow get an angle side pair across each other. You can use sine law. And I will actually always start with my pair. Okay. And this one right here is as easy as it gets. This is just a one step. So you would go sine of 68, make sure it's always sine glued to the angle, and then it's 157.1 meters. I'll put the units down so you know that meters go with meters. And they're asking for this side, and you're given the angle across from it, so this is actually a fairly straightforward example. Side Q, so we're going to use that. This is your setup. So you would get 2 marks. 1 mark for determining that it's sine law, another mark for setting it up correctly, and then 1 more mark for actually solving for Q. So here we multiply that way, we divide going up. So and I always like to put the number in front of, just so that the 52 and the 157, if there's no conflict there. And then you divide by sine of 68. So you grab your calculator, 157.1 times sine of 52 equals, I always press equals, and then I go sine divided by sine of 68. That gives you 133.52, right? We are in meters. That's it. You're done. question. What if they had asked you to find side R right from the get-go? Like not even, they wouldn't have asked for that, they would have asked for this. You would have had to first solve for Q, right? Or find this angle here, I mean, right? Because you knew two angles. You have to find this one first, and because you're already given two, it's easy to find that one, and then solve for that side across from it. Okay, so it's always based on the situation you're in. Next, we have a pair. This is sine law, right? So you know you're going to have to start with sine law. Later on, as soon as you find something, you can switch over to cosine law or vice versa. If you start with cosine law, you can switch over to sine law. But you can only start with one, okay? That's the key. So you have a pair, sine of 112 over 7.9 meters. And they want this angle right here and that side length, right? So the first thing we can do is we're given that side, so we can find sine of, in this case, angle Z, like that. Okay. So this is your unknown. So in this case, you multiply up, you divide down. So sine of Z, not just Z. Okay. A lot of folks just put Z, the angle that needs to be glued to sine until you take the inverse. 6.4 times sine of 112 divided by 7.9. Okay. And then you go sine of Z. Let's figure out what this is. You get 0.7511. Z would be sine inverse of 0.7511. You don't need to have the brackets, but some calculators do it anyways. So I'll take the inverse of that answer, and it's 48.69. Okay, the 8 gets bumped up. So you found the angle. You have that now, right? And now you can find angle X to find side X. Okay, angle X is going to be 180 minus 112 minus 48.69. Right, so this is angle Y. Let's put that Y just above it, and let's put the Z just above it so you know you're subtracting the other two angles from 180 to get X. Okay. That's 19.31 degrees. Now I'm going to use this side over here to solve for X. Just pause for a bit here because I want you to be able to have options, right? You now found that this is 19.31, right? It's technically at this corner here, it's a side angle side. See that? Side angle side. So you could use cosine law to solve for that if you wanted to. But I'm in sine law mode, so I'm just going to continue, right? So I'm going to keep going with the pair that I identified right at the beginning. But now on the other side, I'm going to go sine of that angle up there. And that's going to be able to solve for side X. Okay? So X is going to be, you're going to multiply this way, divide up, right? So 7.9 times sine of 1931 divided by sine of 112. And after today, I'm going to start ACing you a lot more. So I want to see how much of this is now sticking and making sure you understand, right? So I solve for Z, which is what they wanted, and I solve for side X. Angle and side, right? Two different methods. So you need to use the inverse. You're using the inverse if you're trying to find an angle, right? It's very important here. All right, number 2 on the back side here. So the roof line of a ski chalet is asymmetrical. Right? It's symmetrical if you have something like this. If you were to cut this in half, this is symmetrical. Asymmetrical, right, is if it's offset like this, right? It's asymmetrical. That's all it is. Oops, sorry, you can't even see that. Apologize. Right, like it's kind of off. Maybe you can exaggerate a bit more by making it longer like that, right? So asymmetrical. So this roof is asymmetrical, meaning it's slanted like this, right? And let's see what they want. The shorter side is 3.6 meters, so they have 3.6, and the long makes an angle of 65 with the horizontal, and makes a 65 with the horizontal. The longer side makes a 38 with the horizontal. How wide is the chalet? So they want this, and they don't have a, they're basically asking for this, right? How wide? They're asking for this, okay? You have a pair, so you know this is a sine law situation, okay? So I'm going to go sine of 38 over 3.6 meters. And if I want this side, I need the angle across from it. So to get this angle, we're going to just go off to the side here. And we know two of them. So why don't we call this angle X, like capital X at the top here. So X is going to be 180 minus 38 minus 65. So this would be a mark right here. You having to do this on the side would give you a full mark, because it's a concept, right? That's 77 degrees. Underline that because that's important to me. So I'm going to say sine of 77 over side X. So 1 mark for identifying sine law, 1 mark for identifying the 77, another mark for correct setup, and a final mark for the correct final answer. So this would be a 4-mark question in a sense. So 3.6, right, times sine of 77 over sine of 38. You don't need to worry about obtuse angles or anything like that in sine law. That's 5 point, and here is rounding, right? Rounding to 2, the 7 bumps us to a 10, which bumps us to a 7, so it's 5.70 meters. That's what they were really asking. If you had used sine of 65, you would have found this side right here, which is not what they're asking. Think what's the time? Okay. I think I'll give you the answer to 3. But then again, I feel like you need to know. This is a two question and one type of scenario. So I'll actually go through this, okay? Here's that word again, which you shouldn't fear it, but it's talked about, right? The angle of elevation to the top of the tree from point B is 42 degrees, right? So they give you the 42 there. From point C, like you're going closer to the tree now, and you know this, right? The closer you go to an object, the higher up your head has to tilt, right? I hope you know that. Like if you come up to me, if I'm far away from you, you're gonna be like, oh yeah, I get it, I get it. And as I come closer to you, you'll be looking up, right? Your neck is gonna hurt. Because I'm 6'5", right? I'm tall. So that's, you should understand that the angle is gonna get bigger, okay, as you get closer to something. So you step 70 meters closer, and then you have a 58-degree angle of elevation. So how tall is the tree? They want to know this side ultimately, right? This is the height. We're going to call this the height, H for height, right? So what is the height of this tree? We know, by the way, what's the angle formed here between the ground and a tree? It should be 90 degrees, okay? That is implied, meaning like they're assuming you would assume that, right? So there's a 90 degree here. The problem is if you cover this up, like if you cover this up and you try to just work with this triangle, all you know is these two angles here. You don't know any other side. So what we're going to do is we're going to work with this triangle here, and then we're going to move over to this one. So you want to do something with the first triangle to find the side that they share. They share this side. I'm going to do orange here. This side here is shared between the two triangles, and that's the one you want to try to find. Okay? So I'm going to work with triangle 1 out here. What can you get out of this one? Well, this angle here, I'm going to use red for that one. Where's my red pen? We're going to try to find this one here, because this is along a straight line here. So this angle right here, angle C, is going to be 180 minus 58. So angle C is going to be 122, okay? That's this one. That's because these two angles are supplementary, okay? So now, if you have this triangle, let's copy that out here. I'm going to copy this one out. Just try your best. So we know this is 70. We know this is 42 here in this angle there. And we know that this angle right here is 122. Okay. Do you have a pair at all, or does this look like cosine law? It look angle, side, angle. We don't have something like that. We have two angles on one side. Find this angle up here, because you have 2 out of the 3, correct? So it's a bunch of 180 subtract, but notice that this is just 180 minus one angle to get that second one right beside it. This one, you have to go 180 minus 42 minus 122. You have to subtract because all three angles in a triangle add up to 180. So you subtract the two that are known to get that third one. You're probably like, what? There's too many 180s there, right? And that's 16 degrees. So how about this? Because you're going to look back, you're like, what? Where did we even start? I think we should put down step 1. We did this, right? I'm going to go up here. I'm going to put down step 2. We did that. And now I have a pair, right? I have this angle, which is 16, and that side length, which is there. So step 3 is sine of 16 degrees over 70 meters. Okay, is equal to sine, and we want this one here. So we're going to call this x for now. Sine of 42 degrees, right, of this angle over that side length. Cross multiply, it's 70 times sine of 42 divided by sine of 16. And that's 169.93 meters. I'm just going to underline that because it's important, but it's not my final answer yet. So that's step 3. Step 4. This is the last one. We now move over to this one. And I'm going to draw it like this. This is my 90. This is the height. I just found this one, which is 169.93. And I know that this angle here, if you copy it from that triangle, transferred over is 58. You have a pair. Sine that again. So you start with sine of box, which is 90, right, over 169.93 is equal to sine of 58 over h, and you cross multiply and divide. By the way, sine of 90 degrees is 1. So when you divide by sine of 90, it may look like nothing is happening, but it's just a formality. Like, I want you to still remember this is always how to do it, right? So 169.93 times sine of 58, right? 144.10 divided by sine of 90, nothing is going to happen, right? That's normal. And that's 11 meters. So a lot of steps, right? I will add a heading to the top of this. So I'm going to try not to cover everything. I'll just write down multi-triangle example. That way you can, if you flip through your notes, you're like, oh yeah, I remember a multi-triangle where I need to do a whole bunch of stuff. I need to know the relationship between angles that are right beside each other along a straight line. And I need to also remember the property that in a triangle, all angles add up to 180. So if I have 2, I can subtract that from 180 to get that. We'll do more multi-triangle as we go. So I'm going to leave 273 for now. I will just give you the answers though, because then you can practice this right away again if you haven't done so already. I know this one would have been challenging. I understand that. So go to page 273 right now and just write down the answers. Here you get 131.84 meters. This is on page 273. Okay. The height of the cliff is 93.22 meters. And this is 93.22 meters as well. Okay. Now, for the rest of today's class, if you go through your book, to your handouts, right, that booklet, that package I gave you with all the handouts, look for this one right here. It says Law of Sines and Cosines Review Worksheet. And the coolest part about this worksheet, there's a couple of things. You're going to have to determine, am I going to use sine law or cosine law? Okay. If you don't have it, let me know, because somebody helped me putting these together, so I hope they didn't miss that one. If it is missing, I'll have to post a PDF of that online. Okay, the answers are at the back, by the way. Okay, so you don't need me to go over them. But notice what it says. It says solve each triangle. Okay, and it's going to take you a little while. So let me just scan for 1 second. How about we only do the odd ones today? There's just one. Write this down. I'll tell you which ones, because then if you do that, then you're missing out on. I'm going to ask you to do 1, 2, 6, and 7. How's that? Just the 4. Right? Just do 1, 2, 6, and 7. So what you want to do is solve, like in this case, solving the triangle means to solve for all 3 angles, right? And I told you, I hope you remember that if you're not told which one to solve for, you solve for the largest angle first, right? So in this case, 26 is the longest side, so solve for B first, and so forth. You can use your study sheet, you can use your notes, and the answers are at the back. So let's do that for the rest of today. And I encourage you to do those on your own time if you don't finish.